Hello and welcome back to another video. Today we are going to be talking about IB Math SL. Specifically, and yes, this is important this time, we are exclusively talking about SL Math, not HL Math. I will only be covering the formula booklet with the information and the formulas for the SL course, not the HL course. Could I probably talk about the HL? Yes, but will I? No, because I don't have to know that. All right, so if you didn't gather from that long-winded introduction, today we are going to be going over all of the formulas in the formula booklet. And the reason why I think this is an important video to watch, whether you're at the beginning of your IB journey or the very end of your IB journey, is because this is the booklet you are going to have access to when you take the test. That's right. When you take the test, you're going to get access to this booklet and a calculator for both papers the entire time. It's a really, really big privilege to have access to that, so I really recommend you take advantage of it and know your formulas and know where they are in the book. If you have the ability, I would print yourself out a physical copy of the formula booklet and familiarize with how it looks in your hand. It seems silly, but when you get the idea of how many pages to flip back and forth for specific topics, you will be much faster and much more efficient on the exam. Flipping between formulas is one of the things that you will need to do. Now, a very brief overview of the exam, since I haven't done one here and I think it's kind of important. There are two papers. Paper 1 is going to be shorter questions with more of them. It's going to be maybe 4 marks a question, and they're not going to be very long. The parts will build on each other, like A, B, C, whatever, but you won't have very many parts. Whereas paper 2 is going to be fewer, very long questions. I'm talking 15 marks a pop here, roughly. And they're going to have A, B, C, D, E, F, J, you name a letter, it's probably there, and they are going to build on one another, and you're going to want to know, for both papers, where to look in your formula booklet to find the formula you need, and if there is a formula you need. If you spend the whole time searching for a formula that isn't even on the paper, then that is going to be really sad for you. All right, so let's get right into it. So the first examination for this test, you can see in the corner, I can put us on little laser mode here, hold on, little laser mode. You can see that here, it clearly says that the first examination was in 2021. Obviously, things happened, but this year, 2022, May and onward, this is going to be the formula booklet. All right, so here we can see that it does give us the content. So if you really are struggling and you know that it's in one of these 5 topics, or the prior learning section, but you don't know exactly where, you can refer here. Again, we are only going to be looking at the SL and HL part, not the HL only. So keep that in mind as you watch this video, that if you are taking the HL exam, while you still can glean helpful information from this, I think I've scratched out every page that has HL only, or just deleted the pages that are exclusively HL. All right. So, prior learnings. This is the stuff that you might not have explicitly learned about in class, but you were expected to learn about before you got into the class, or that you were expected to know when you got to the unit that you used this information. For a lot of this, the geometry section did refer back to it. So like area of a parallelogram is just going to be base times height. Not anything too difficult. Area of a triangle. There is going to be another area of a triangle formula, but if that one, for whatever reason, doesn't work, we do have the alternative in here. Area of a trapezoid, I don't think I've ever seen used in class, but it's there in case you need it. Area of a circle is going to be kind of an important one. I have seen that in class quite frequently, and that is going to be pi r squared. These are formulas you probably have memorized or have at least heard over and over and over again, so I'm not going to go too in-depth onto how to use these. Just know they're here in case you need it. Circumference of a circle, volume of a cuboid. A cuboid is just going to be a cube, regular cube. It's called a cuboid because Britain. Volume of a cylinder is kind of an interesting one. We will see this quite frequently, but anytime we have an area of a prism, or really any area of a 3D object that has a base that is a shape with the base and the top both being the same shape, you're just going to multiply by the area and of the base and height. And that is true for the cylinder, because we can see the pi r squared is going to be the same pi r squared from up there times the height. Why they felt the need to specify The cylinder, the only thing I can think is that it doesn't classify as a prism, and therefore it needed to include it as well. But here is our volume of a prism. As we just talked about, area times height. Area times height, that is going to come in handy for you when you are talking about derivatives or in general just talking about geometry. Area of a curved surface of a cylinder. So we get really, really picky here in IB Math, and if you're talking about the area, exclusively the area of the cylinder, so just the outside part, you're going to need to do 2 circles and add them to 1 curved surface of the cylinder. Why? Because this is IB Math, and it doesn't need to be logical. Now, the last 2 here are kind of special because they will come up pretty much verbatim when we get to their section. The only difference will be that we will be seeing an X, a Y, and a Z. And we'll get there when we get there. I'm not too pressed about it at the minute, but it is something to keep in mind that we are going to see that as well. Distance is going to be pretty, again, these are pretty standard. Distance between any 2 points is going to be the first point minus the second point, and you can do the points in any order as long as they're consistent for both x and y. Squared plus the y1 minus y2 squared, right? And then coordinates of a midpoint should make sense to you. It's the x1 plus x2, or if you really care that much, x2 plus x1 divided by 2, and the same thing for y1 plus y2 divided by 2. Again, I've scratched out the HL here. Sorry, it's kind of messy. Get used to it. Moving on. Now, you'll see I've taken some notes here, and I'm going to use these kind of as talking points just because I feel like it makes it a little bit easier. So if you don't mind me zooming in here, you will also take note of the fact that not every lesson is covered with a formula. You don't need to know some formulas. They won't be on the exam. Every formula that you will need to know for the exam will be on this paper. If you are faced with a shape like a hexagon that you don't see the formula in the booklet, there is an alternative method to finding the area of that shape. And that is the method that they want you to use. That is the method you will get points for. All right. So let's talk about arithmetic sequences. So for sequences, arithmetic and geometric, you will almost always be told whether it's an arithmetic sequence or geometric sequence. Now, I do say almost always. There are situations in which you will not be told exclusively or explicitly, which one it is. And in that case, you are expected to know. But let me tell you a little quick and dirty trick that should be very easy for you to remember. Geometric sequences are always going to be multiplying. So they might be increasing by 12% or decreasing by 43% or whatever, whereas arithmetic sequences are going to be adding the same amount every time. So I saw a question recently where it was like, I have 6 candies and I eat 1 every hour, but the first hour I ate 3. Then your U1, your first term, would be -3 because you're eating. Not actually. This is a bad problem. I shouldn't make up problems in my head on the fly. But my point is you're taking away the same amount every time except for the first time. The first time is the only time where it doesn't have to fit that criteria and it can still be an arithmetic sequence. It's also pretty easy to keep in mind the idea that these are going to be very simple. They're not going to be anything crazy. They're not going to be anything too intense. It should be fairly easy for you to both identify which is which and utilize the numbers that they're giving you. So the U of n is always going to be whatever you want. So whatever we want is n. So if we want the 6th candy that I ate, then we would put in U6, U of 6, right? So that is the term you want. That n is going to transfer over to here, the number of desired. That is the term. The first term is going to be U1. This should make sense. U1 is always going to be the first one. So if you say the third one after the first, that would be n is 4, right? And then the only the only variable that could be slightly confusing here is d. And d is going to be the common difference. So when we say difference, we usually think of subtraction. But in this case, difference can also be referring to addition or any change or difference between one n and another n. And that is going to be our common difference. Another note here before we move on too far is that your U1 doesn't necessarily have to be the first term. And what I mean by that is if the problem only gives you term 5 and term 7, then you use term 5 as term 1 and term 7 as term 3. A little bit complicated. That is the only situation in which I can really see this sequence tripping anybody up is if they do that and they ask you to go back and talk about U1. It is possible that they do that. The reason why you would do it that way is so that you can get D, because you would have access to all of the other variables. You would only be missing D, and that is a pretty easy way that you could get that, and then you could use D to get the original U1. Makes sense? Good. Great. Glad it makes sense. So then we also have the sum. The sum is going to be slightly more complicated, but the terms are going to be pretty much the same. The sum of n, again, n is the term we want. N is going to be in place here and here again. They have two different equations for sum. I really prefer to use this one just because that's the one I always use. It can be used in almost every situation. There's an area situation which you'd need to use this one. You will be more likely always able to use this one, and this is only for when you already have that U of n. So I recommend just kind of ignoring this one and focusing on this one. But whatever you are comfortable with is fine. But again, we're using that n. It's going to be the sum, meaning that this is every single term leading up to this added together. So if you have a question that asks you if there are 5 ladybugs the first day, and then there are 2 additional ladybugs every day after that, and you count the ladybugs every 6 hours, then you can find the sum and multiply it by 6. Like, kind of convoluted, kind of stupid, but as long as you have an idea of how to get terms with the equation and what the equation means in this situation, you should be fine. And so for that reason, I won't really be going into too terribly much depth with the geometric sequences because they're basically the same thing. R is going to be the rate of geometric growth. N is still going to be the term we want, and U1 is still going to be the term we want. Keep in mind that these are being multiplied together, not added. So let's talk a little bit about R for just a minute here. Think about when you do any sort of multiplication with a decimal that starts 0 point whatever. You are always going to get a smaller number than what you're multiplying against. So if you do 2 times 0.5, you are going to get 1, and that is going to be less than 2. So if you have a problem that says something increases by 50% every time, then you would want to do 2 times 1.5, and R is going to be the 1.5, not just the 1, not just the 0.5, the 1.5. If you just do the 0.5, you're going to be decreasing by 50% every time. Right. And so the other thing to keep in mind is that if they already give you a percentage, you are going to want to put that in a fraction form. So if you have 1.2%, you are going to make that 0.012%, right? Because the decimal point is going to move 2 spaces over. Great. Glad we're all on the same page. Also, I can't hear anyone. Nobody's here. I'm really talking to myself. All right, so then we have the sum, same deal. R is going to be that same number that we just discussed, except we're not going to take the exponent. The exponent's going to be slightly different for all 3 of these equations, all 3 of these uses of R, so just keep that in mind when you do it. R can never equal 1 because that would get us 0 in the denominator, and that's not possible. If you ever have an answer with a 0 in the denominator, throw it out. Throw it out and start over, or if you get multiple answers, don't include that one. You are going to get points off if you include an answer with 0 in the denominator. So let's talk about compound interest. So you will see here that we actually have a formula for compound interest, but you will also see here I'm 0% interested in that formula, and the reason why is because your calculator has a finance app. So if you pick up your TI-84 calculator, yours might be digital. The one I have here at home is the TI-84 Plus Silver Edition. I know, fancy. You press the on button, then you click Apps, Finance, and then TVM Solvers. That is probably just going to be the purple Apps button. It is for me, and then enter, and that is going to get you to a TVM solver. Now, The nice thing about this, and the reason why I say we don't need this formula at all, is because you can get basically the marks for doing the problem if you write down this information. Now, if you're looking at the screen of your calculator, you're going to see these letters and potentially numbers or potentially nothing next to them. NI percent, PV, PMT, FV, P/Y, C/Y, and then end begin. All right? End begin is not important. You should always keep it on end, though it really doesn't matter for our situation. Now, the reason why I say that you need to write down these things from your calculator when you do the problem is because those are going to get you your marks for doing the problem. Instead of putting all the information into the problem and putting it into a formula and doing it by hand, that takes forever. We don't want to do that. I don't want to do that. So we're going to write down these things. Keep in mind that any of these things you could be solving for. Probably not PMT, probably not PY, and probably not CY. But really any of the other ones, years, interest, start value, or final value, I can see them asking a question for. Keep in mind that when you are trying to solve an equation, you're going to write down n equals whatever, I percent equals whatever, PV equals whatever. If there is no PMT, put PMT equals 0. Always write PMT equals 0. Don't just leave it out, because if you leave it out, there's a chance that they'll think you forgot it, and then you could lose that point. FV, if you're not solving for it, equals whatever it is. PY is going to be payments for years, so that's only going to really matter if you are putting in a payment, in which case it should match your compounded per year. If you're not putting it in, put in 1, and then compounded for year. So I have it written here, but yearly is going to be 1, semi-annually is going to be 2, quarterly is going to be 4, monthly is going to be 12, and you can figure out the rest from there. The only one that I think is slightly confusing is semi-annually, and that is just 2 times a year. It's 2 times a year. So the other thing to keep in mind when you are putting these values in, and this is something you're going to want to note down when you're writing down these values when you do this problem, is that either PV or FV is going to need to be negative. Don't ask me why, because I can't tell you. I have no idea, but it should be negative. So write that down, and then when you want to solve, you're going to hover over the one that you want to solve for. Instead of putting in a number, you're going to select alpha, enter, and that is going to put you in the solve button that's in the green above the enter button. And it will solve it for you and give you that number, and then you write down that for FV equals 2. Great, you just did the problem, move on with your life. All right, let's talk about exponents and logarithms. I can't really see too many situations in which you would be needing to use this, but it is nice that it's here because then you don't have to memorize it. I wrote it down here as well just because it made sense for me to remember that a non-base is always going to be 10. This is a pretty self-explanatory formula. A, X, X, B, good enough. Let's move on. Keep in mind that they can't be these numbers. You know these things. So percentage error, I actually got a question wrong pretty recently because I didn't look at the nice helpful text after the formula. And this is your big fat tip for that. Always read the text after the formula if you have any, and I do mean any questions about it. Because I, for whatever reason, without looking at this, thought that the A was going to mean actual and the E was going to mean estimate, and that is not true. E is exact and A is approximate. I think that is terrible letters to use because of the reason that I just shared, but it's there. Keep in mind that these little bars here are going to be absolute value. Absolute value is just going to mean that it's always going to be positive. If it asks for a decimal, then you don't multiply it by the percent, but if it's asking for a decimal, if it's asking for a percent, do multiply it. Let's move on to functions. All right, these are going to be the easiest things that you have ever heard of because you have done them since Algebra 1. Y equals mx plus c or mx plus b. Doesn't matter what letter you use, just know that it's there. Or it could be ax plus by plus d equals 0. Or it could be y minus y1 equals mx minus x1. These are all formulas that you have seen over and over and over. You are an IB junior or senior. You know these things. You don't need me to go over them. Same thing for the gradient formula, though I will say, the one thing I will say about this is that keep in mind we're going y2 to y1 and then x2 to x1. Always keep it consistent. When in doubt, just keep it consistent. It's the axis of symmetry. I even wrote down self-explanatory. I'm just now seeing that. The axis of symmetry, when you have a quadratic formula, this is going to be the axis of symmetry. It is the axis of which there is symmetry, duh. The B and the B, the A and the A, the X and the X's, it's all going to carry over. Keep in mind that there is a little negative sign there. Great, moving on. Look, I started using red, aren't I? Fancy. Great, let's get started. So I wrote it up here, to be used with shapes. So when we have Z, we have a multi-planed situation. So this might be you are given a cube and, okay, I can't draw it fast enough. You're given a cube, you need to solve for a point that is like a diagonal on all three planes. You use this formula, you find the distance, good job, you did it. Again, keep x, y, and z consistent. We already talked about this with the other formula, x1, x2, y1, y2, z1, z2. They're always going to be in order. This is always going to be the order of the components. So it's going to be x, comma, y, comma, z. When you see it, that's how you should give your answers too. It's the same thing for the midpoint formula, nothing special. You don't even have to keep it consistent there. Just keep in mind the midpoint is going to find the exact middle point. This isn't hard stuff, guys. The volume of a right pyramid. So what do I mean by a right pyramid? I just mean a pyramid, guys. I just mean a pyramid. Okay? I just mean a pyramid. It's going to be a square pyramid. This is a terrible drawing of a pyramid. Okay, moving on. This is the formula. Area, again. Height, again. Great. I guess you could, in theory, also don't really need this formula because this is going to be your circle. This is going to be your base. The circle is the base, but I guess it's not technically a pyramid, so we had to put it as a separate formula. Anyways, so this is going to be the area. Keep in mind we were just doing volume, but now we're doing area. The area of a curved surface of a cone. Again, if you need to do the area of a cone as a whole, you need to do this curved surface and add it to one this time, one circle. When we did the cylinder, we did two circles because cylinders have a top and a bottom, whereas cones are just going to have one bottom. Volume of a sphere, self-explanatory. Surface area of a sphere, self-explanatory. Radius, we're always talking about radius. It says that here. I'm saying it anyways. Yeah. So sine rule and cosine rule. So these two kind of go together. So let me zoom in because I know I took some pretty tiny notes. Lowercase is always going to be the side. It's going to be the side here. It's going to be the side here. It's always going to be the side, whereas the uppercase is always going to be the angle. When you look at your calculator, you are going to see right above the comma, parentheses buttons, sine, cosine, and tangent. Sine, cosine, and tangent are the buttons that you're going to use to get these. All right? When you are needing to use a specific whatever, always keep it consistent. See this running theme? Keep it consistent. Side, 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 angle, angle, angle. Keep it consistent. And I wrote it here. You can go the other way too. You can go angle, 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 side, 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 as long as you keep the sign with the angle and you keep it consistent among all of the ones. You only technically need to do it for two. So it puts it here as the third one because you can do it with the third one, but for solving purposes, you only need to do it with two. If you are missing just one part, then you can input all the others and find it pretty easily, right? Use your brain here, guys. Sine, think of SOHCAHTOA. If you've never learned SOHCAHTOA, well, today is your lucky day. SOHCAHTOA. Sine is the opposite over the hypotenuse. So look at the opposite side and the hypotenuse side. All right? You know, this isn't groundbreaking stuff. So then let's look at the cosine rule. There are two versions of the cosine rule, this one and this one. If you have the angle and you need the side, good for you, there's a formula for that. And vice versa, if you only have sides and you need an angle, well, hot dog. Isn't that great? If you need to transfer the cosine over, use arc cosine. Or it also is known as cosine to the -1. And that's how it's going to look on your calculator. It is going to be the second cosine on your calculator. Second cosine. It is the blue above the cosine. All right. Let's talk about the area of the triangle. I said there was another formula. Here it is. Again, side A and B with angle C. So if you have a triangle and this is A and this is B, this is going to be C. Great, we've covered it. Moving on, length of an arc. Theta. Theta is going to be the angle in degrees. Make sure that your calculator is in degree mode. All right, great. R is still going to be the radius. Moving on. I don't know. So the quartile ranges. The quartile ranges are what we're going to use for interquartile range. They're going to be the box and whisker plot stuff. Quadrant 3 and quadrant 1 is going to get you that interquartile range. Keep in mind that this is a range and these are just single numbers. So full number divide by 2, so if you are looking for the quadrants, you take the full number and then divide it by 2, divide each of those by 2, and that's going to get your lower is quadrant 1 and your upper is quadrant 3. This second formula here for mean is going to be in your calculator. You see these big, scary summations, and there's all these numbers. Don't need to know any of that. This symbol, this one right here, is going to be the same symbol you are going to see in your calculator. So let me tell you how to do it. You are going to click on. That's a great place to start. Stat. It's going to be up at the top there. Edit or 1. You could do either, is enter to get to edit, or 1. Then you're going to put in your numbers. L1 is going to be the first section of your table. This is going to be Y1 or L1. This is going to be L2. And you're going to enter them just right down the line. Make sure they connect. Make sure you've entered them correctly. And then you can go ahead and find your stats, your variable stats. And that is going to be stat calc, which is 1 over from edit, and then variable stats. All right. And that you're going to see that little symbol, and that's going to be your mean. Very simple. Don't even mess with the formula. To be honest, I think some of the times these formulas are on there in case your calculator dies or something happens to it. You can still pass the exam, and that's why they give it to you. But in all honesty, don't mess with them if you don't have to. All right, so now we are looking at probability. I have done an entire video, maybe even 2, I can't remember, on probability. I have already covered probability. Go there. Go there if you want extra help. I'm going to rapid fire these as best I can because I have already talked about them. All right. So probability of an event A is the number of the event, number of events in A divided by the number of events in the entire sample. U is going to be the entire sample. The probability of, we're going to see that P again, A. That is what we've just got here. Plus the complement, which is the event not happening. So that is going to be A minus 1. Shocker, they add together to get 1. It's almost like I just told you that. So if you have the complement and you need to get the original, use this formula, or vice versa. If you have the original, you need the complement, use the formula. If you have neither, use this formula, then this formula. Okay, moving on. Combined events. If we have a union, we're looking for a union. That includes both events or either event. That means it is all of the things in the Venn diagram for those events. It is going to be PA. Again, we just got that. PV, same formula, but with B. And then minus one intersection, because if we just look at PA or PB, then we are going to have two intersections. We only want one. So both events are already going to include an intersection, so we need to take out one so that we have an accurate representation of both of those events with one intersection. If we are looking for this intersection, if we're looking for the union of mutually exclusive events, this means there are no interlaps or no intersections. You don't need to subtract that because there's nothing to subtract. Moving right along, conditional property. If we are given A, we need to find B. Sorry, we're given B and we need to find A. We're given B, we need to find A. We're given B, we need to find A. I don't know why I didn't write that down. I think I got bored. You're given B, you need to find A. You're going to use the intersection, and then you're going to divide it by the probability of B as a whole. Remember, that is going to include that intersection, one of them, and this is going to be just one intersection as well. Independent events are going to be events that don't rely on each other, but we're looking for them in tandem. So when you think of tree diagrams, this is when you want to use those. If you want to just find this, you're going to subtract this, or you're going to multiply that times that, right? Great. So you're multiplying the events to get their intersection. The intersection in this case is the goal because the intersection would be when both of those events are happening. So if you want to know when both event A and event B, what the probability of both of them happening in that order is, you would use that formula. So then we get on to EX. I believe this is the other video that I've done already. So I won't cover this in too much depth, but the expected value of a discrete random variable X is just going to be the summation of all of those events times the probability of them occurring. Adding just the probabilities of all of these events should always get you 1 on a I can't even remember. I should really make myself a note to check this or watch my own video. Jesus. And then down here, the mean and the variance. Again, that's going to be for binomial distribution. Let me tell you a really good tool. All right, we're going to go to our calculator. We're going to go to second vars. That is going to take us to distribution, which is what we're doing. For binomial distribution, we are going to scroll to either, for me, it is 0 for PDF or A for CDF. I won't cover them in this video because I've already done a video on them. You can check the playlist with the math videos on my channel if you want to watch them. Or you could also do normal PDF and normal CDF. The formulas here is going to be the number and the probability, and the number and the probability times 1 minus the probability. Great, moving on. So let's talk about calculus. So I know a lot of people got not very lucky last year with AP Calc. Either they didn't take it or they dropped out because of virtual learning. I happen to do really good on calculus, which is why I didn't take any notes on these formulas because I already have them memorized. So I will just run down very quickly since I already know what I'm talking about with these. Anyways, so power rule is going to be x to the n is going to be the same thing as nx time to the power of n minus 1, right? We're dropping the n, we're subtracting 1. The integral is going to be the opposite, except we have to account for plus c. So we are going to be dividing by n so that we can, n plus 1, sorry. We're going to be dividing by n plus 1 in this case. And then the exponent is also going to be n plus 1. But we also have to account for plus c because anytime we have just a plus 6, that is going to go to 0 when we take the derivative. So we need to account for that because we don't know what the value of c is in this case. And that can be solved with this formula. Area of an enclosed curve, area enclosed by a curve. So it is going to be B and A. This is the bottom, this is the top. This is, you know the drill. If these are both the same number, it's going to be 0 every time. Don't even do yourself the danger of doing the derivative or doing the integral. The trapezoidal rule is when we're approximating the area of under a curve, we might want to use trapezoids because they're one of the best ways to approximate this curve without actually doing the work of finding the curve. You are going to, I mean, come on, guys. Come on. Do you really need me to go over this formula? Go look at somebody else's video. Go find an AP Calc video. If you're that confused, I'm not going over it. It takes forever. And I've done my due diligence. And I'm not teaching you calculus. Especially because I'm not 100% sure how much calculus is actually going to be on this particular exam. Anyways, that was the video. Bye.